In recent months, the landscape of American science and academia has undergone significant upheaval, prompting a wave of researchers to seek opportunities beyond U.S. borders. This emerging trend is largely attributed to the Trump administration's sweeping cuts to science funding and workforce reductions, which have left many in the scientific community feeling destabilized and uncertain about their future. A new analysis from Nature reveals that applications from U.S. scientists for jobs abroad surged by 32% from January to March 2025 compared to the same period in 2024. Concurrently, interest in international roles has skyrocketed, with views of overseas job postings increasing by 35%. March alone saw a staggering 68% jump in job views during a time when the administration intensified its funding cuts, signaling a significant shift in the mindset of American researchers. The impact of these cuts has been felt acutely across various domains of scientific research. For instance, over 200 federal grants aimed at HIV and AIDS research were abruptly terminated last month, alongside reductions in funding for critical COVID-19 studies. In another instance, Columbia University faced a $400 million funding cut due to campus protests related to the Israeli-Palestinian conflict. James Richards, who leads the Global Talent Solutions team at Springer Nature, noted the unprecedented nature of the current job application trends, saying, "To see this big drop in views and applications to the U.S. and the similar rise in those looking to leave is unprecedented." The sentiment of discontent is echoed by many researchers. Valerie Neiman, a chemical engineer who recently transitioned from Stanford University to a postdoctoral position at the University of Bern, highlighted the instability in U.S. academic positions. "People don't know how long their postdocs will be," she remarked. "We can't apply for fellowships because we don't know how long they're going to exist." The gravity of the situation was further underscored by a survey conducted by Nature, which found that 75% of researchers expressed a desire to leave the United States for better opportunities. Applications from U.S. scientists to Canada specifically increased by 41%, while the number of Canadian researchers applying for jobs in the U.S. dropped by 13%. The data paints a clear picture of a shifting scientific workforce, with many viewing international opportunities as more stable and promising. European institutions are keen to capitalize on this potential exodus. Aix-Marseille University in France, for example, launched the Safe Place for Science initiative, allocating €15 million to attract researchers who have been affected by the U.S. administration's policies. Clara Buffy, a spokesperson for the university, noted the overwhelming response to the initiative. With nearly 300 applications from American researchers seeking a more supportive environment for their work. As American scientists explore these new horizons, the implications for U.S. research could be profound. The loss of talent may lead to a brain drain that not only hampers innovation but also undermines the country's global standing in scientific research. Institutions like the Max Planck Society in Germany are already observing increased interest from U.S. researchers looking to extend their stays abroad, illustrating the shifting dynamics of the global scientific community. As this trend continues to unfold, it raises critical questions about the future of U.S. science. Will the administration reconsider its approach to funding and support for research? Will American institutions adapt to retain talent amidst growing competition from abroad? The answers remain uncertain, but one thing is clear: the current environment is prompting many researchers to rethink their career trajectories, leading to a significant reshaping of the scientific landscape. As scientists seek refuge and opportunity beyond U.S. borders, the long-term effects of these trends on American science and academia will require close observation and response. As the world grapples with the rapid evolution of biotechnology, a significant spotlight is being cast on the upcoming American Association for Cancer Research AACR 2025 conference, where domestic pharmaceutical and biotechnology firms are set to showcase their latest innovations. Taking place from April 25 to 30 in Chicago, this prestigious event is recognized as one of the foremost gatherings for cancer research, alongside the American Society of Clinical Oncology (ASCO) and the European Society for Medical Oncology (ESMO). With over 20,000 attendees expected, including corporate representatives and researchers, AACR serves not only as a platform for sharing groundbreaking research but also as a vital venue for technology export opportunities. This year, the conference will highlight a variety of new drug research initiatives utilizing advanced modality technologies. These technologies focus on accurately delivering drugs to cancer cells and developing diverse new drug candidates. Among the most exciting advancements are multi-antibody therapies and antibody-drug conjugates (ADCs) designed to enhance the efficacy of cancer treatments. As major pharmaceutical companies increasingly pursue acquisitions of these cutting-edge technologies, the potential for scalable applications across various diseases becomes evident. Celltrion, a leading domestic corporation, is poised to unveil the preclinical results of its multi-antibody anti-cancer drug candidate CTP-72 developed in collaboration with AACR. This candidate represents a significant leap in targeting multiple antigens on cancer cells, thereby amplifying the therapeutic response. Similarly, ABL Bio and Yuhan Corporation will present non-clinical data on their jointly developed dual antibody anti-cancer drug ABL-104, showcasing the promising future of multi-targeted therapies. The ADC technology, which involves attaching drugs to antibodies for precise delivery to cancer cells, has been likened to a missile accurately striking its target. LigaChem Biosciences, which has already established partnerships to export its ADC platform internationally, will present preclinical results for its anti-cancer drug candidates at the AACR. Celltrion Pharm is also set to showcase its dual drug ADC platform CTPH-02, which combines different principles of anti-cancer drugs, demonstrating the potential for enhanced therapeutic effects. Furthermore, research into mRNA-based anti-cancer drugs is gaining traction. Hanmi Pharmaceutical will share results from its non-clinical studies, including a candidate designed to express the p53 protein, an important anti-cancer agent, through mRNA technology. This innovative approach illustrates the shift towards personalized medicine, where treatments are tailored to the unique genetic makeup of individual patients. As the focus on precision medicine intensifies, technologies that enhance the accuracy of cancer diagnostics are also set to garner attention at AACR. GeneSeeker will present its groundbreaking NewtSeq technology, which utilizes an ultra-sensitive CRISPR gene editing tool for the detection of cancer mutations. Hyo Jun-suk, co-CEO of GeneSeeker, emphasized the importance of this technology, stating, "NewtSeq can sensitively analyze small amounts of mutated cancer genes that were previously difficult to detect." Artificial intelligence (AI) is further revolutionizing cancer treatment approaches, with Lunit poised to reveal research findings that utilize its AI platform LunitScope to analyze patient tissue and predict responses to immunotherapy. CEO Seo Byung-suk highlighted the platform's capability to deliver significant therapeutic predictions even for rare cancers, reinforcing the role of AI in enhancing treatment outcomes. As domestic companies prepare to showcase their innovations at AACR 2025, the potential for collaboration with global pharmaceutical and biotechnology firms is clearer than ever. The conference not only serves as a platform for presenting new research but is also a critical opportunity for technology transfer and fostering international partnerships. With the rapid advancements in cancer therapeutics and diagnostics, the future of oncology research appears bright, marking a significant step forward in the fight against cancer. Looking ahead, the developments presented at AACR 2025 are likely to shape the landscape of cancer treatment for years to come, as researchers and companies continue to innovate. The integration of cutting-edge technologies and novel drug modalities holds the promise of improving patient outcomes and revolutionizing the approach to cancer therapy. The collaboration fostered at AACR may well lead to breakthroughs that redefine the capabilities of modern medicine in combating one of humanity's most challenging adversaries. In a troubling intersection of immigration policy and scientific advancement, the ongoing detention of Harvard scientist Ksenia Petrova has raised alarms about the future of cancer research and diagnostics. Petrova, a pivotal figure in developing data analysis tools for a groundbreaking microscope at Harvard Medical School, has been held in an immigration detention center for over 2 months following her arrest at Boston's Logan International Airport. Her case exemplifies the broader challenges faced by international researchers in the United States, where increasingly stringent immigration policies threaten to stifle innovation and collaboration. Petrova's expertise in computational biology is critical to unlocking the potential of new images generated by a state-of-the-art microscope at the Kirshner lab. Unfortunately, her detention comes at a time when her skills are urgently needed to further research aimed at early cancer detection. The 30-year-old scientist, originally from Russia, was taken into custody for allegedly failing to declare scientific samples, specifically frog embryos intended for research. While such customs violations typically result in fines, Petrova's J-1 scholar visa was revoked, a decision her attorney Gregory Romanovsky argues is disproportionate and indicative of a broader hostile climate for non-citizen academics. "I would call it a grinding machine," Petrova remarked during a video call from the Richwood Correctional Center in Louisiana, encapsulating the dehumanizing experience many detainees face. She expressed fear for her safety should she be deported back to Russia, where she has participated in protests against the war in Ukraine. Petrova's detention not only jeopardizes her future but also poses significant risks to the ongoing research she supports. "Without her, I fully believe that all the insights into cures or fundamental biology that we could make will not be made," said Dr. William Trim, a postdoctoral fellow and colleague. The implications of Petrova's case extend far beyond her individual situation. Dr. Leon Peshkin, her manager at Harvard, highlighted that the fear of detention and deportation is already leading to a chilling effect among international scholars. A recent survey indicated that 75% of the 1,600 scientists polled are considering relocating to Europe or Canada due to the restrictive environment created by U.S. immigration policies. This shift could have dire consequences for the future of medical research in the United States, where talent retention is critical for progress. The scientific community is rallying around Petrova, with colleagues expressing deep concern over the potential loss of her unique skills and the broader impact on research efforts. "She was the only person in our lab who could seamlessly integrate embryology, applied mathematics, modeling, data analysis, and bioinformatics," Peshkin stated, underscoring her irreplaceable role. As scientists await the outcome of Petrova's immigration hearing, the situation has amplified discussions about the necessity of reforming immigration policies to protect the contributions of international scholars in the U.S. In a parallel development, advances in cancer treatment were showcased at the recent European Conference on Interventional Oncology, where AACR Medical highlighted its ProSense cryoablation technology. This minimally invasive technique, which destroys tumors by freezing them, is gaining traction as a preferred alternative to traditional surgical methods. With promising data showing high patient satisfaction rates and low complication risks, ProSense could change the landscape for breast cancer treatment. As the medical community explores new methodologies in cancer care, the unfortunate detainment of researchers like Petrova serves as a stark reminder of the potential barriers that may hinder scientific progress and innovation. As Petrova's case unfolds, the scientific community remains hopeful while grappling with the implications of restrictive immigration policies. The outcome of her legal proceedings may not only determine her fate but also signal the future of international collaboration and research in the United States. With the stakes so high, the call for a more welcoming environment for international talent in academia has never been more urgent. In an era where the influence of artificial intelligence (AI) pervades every facet of business operations, the University of Virginia Darden School of Business is stepping up to meet this challenge head-on. As of April 22, 2025, Darden has unveiled a new MBA concentration focused on artificial intelligence, data analytics, and decision sciences, an initiative designed to equip students with the necessary skills to thrive in a rapidly evolving job market increasingly shaped by data-driven decision-making. The introduction of this concentration comes in response to a growing demand from employers for professionals adept in leveraging data science and AI to enhance organizational effectiveness. Darden's offering will prepare students to contribute to and lead organizations that use data science and artificial intelligence as part of their core business processes. Stated Yael Grushka-Kakane, Vice Dean and Senior Associate Dean for Professional Degree Programs at UVA Darden. Students who complete the concentration will bring proven analytical and quantitative abilities to employers. This strategic move reflects Darden's ongoing commitment to innovation in business education. The school has long been at the forefront of integrating analytics into its curriculum, offering joint degree programs in collaboration with the UVA McIntyre School of Commerce and the School of Data Science. In September 2024, Darden further solidified its dedication to ethical AI practices by establishing the Lacrosse Institute for Ethical Artificial Intelligence in Business, funded by a generous donation from alumnus David Lacrosse and his wife Kathy. The newly introduced concentration allows students to select from 25 specialized courses, requiring the completion of at least 6 to gain in-depth knowledge and practical experience in the field. This enriching academic structure not only aligns with current industry needs but also enhances Darden's already notable reputation, as recently highlighted by U.S. News & World Report. Darden boasts the highest employed graduation rate among U.S. business schools, further underscoring its effectiveness in preparing graduates for successful careers. In addition to the new concentration, Darden continues to offer traditional areas of study including corporate finance, strategy, consulting, and entrepreneurship. This diverse curriculum is designed to cater to a wide array of student interests, ensuring that every graduate can find a pathway that resonates with their aspirations. Looking forward, the integration of AI and data sciences into business education is expected to influence not only the academic landscape but also the broader job market. As organizations increasingly rely on data-driven insights, graduates from Darden's MBA program are well positioned to lead this transformation. The anticipation surrounding this new concentration suggests that the demand for skilled professionals in AI and analytics will only continue to grow, making Darden's initiative a timely and essential response to the needs of today's business environment. As the landscape of business education evolves, the University of Virginia Darden School of Business's commitment to integrating AI and data analytics into its curriculum stands as a testament to the institution's forward-thinking approach. With the implementation of this new concentration, Darden is not only preparing its students for the challenges of the present but also shaping the leaders of tomorrow who will navigate the complexities of an increasingly data-centric world. The success of this initiative may very well set a precedent for other educational institutions aiming to keep pace with technological advancements in business. In a groundbreaking development that could redefine the future of energy production, researchers at the Idaho National Laboratory (INL) are making significant strides towards the commercialization of nuclear fusion energy. This advancement comes with the introduction of a high-tech fusion blanket, a critical component designed to enhance the efficiency and sustainability of fusion reactors. As fusion technology progresses, experts believe it may offer a viable alternative to traditional energy sources, potentially delivering limitless clean energy to the grid. The fusion blanket functions as a crucial intermediary within a fusion reactor, positioned between the reactor's magnets and the vacuum chamber that houses the plasma core. Its primary roles include generating new fuel for the reactor, converting fusion energy into heat for electricity, and safeguarding the reactor's magnetic components from damage. According to a recent press release from INL, the blanket technology could significantly advance the United States' efforts in developing an operational fuel cycle within the next decade. Notably, the fusion blanket leverages lithium to interact with neutrons produced during the fusion reactions, facilitating the production of tritium, an isotope of hydrogen necessary for sustaining the fusion process. This capability could lead to tritium self-sufficiency, thereby ensuring continuous reactor operation. Aaron Washington, a representative from Tokamak Energy, emphasized the blanket's importance, stating, "Fusion blankets are pivotal to delivering limitless fusion energy to the grid." While the fusion blanket technology is under testing at INL, It benefits from the laboratory's existing expertise in nuclear fission, allowing researchers to experiment in a nuclear environment without the immediate need for costly dedicated fusion facilities. This innovative approach is supported by the Department of Energy's Fusion Innovative Research Engine FIRE collaboratives, which aim to foster a science and technology ecosystem focused on fusion energy. In parallel with these developments, the field of nuclear fusion is witnessing significant international collaboration, exemplified by the ongoing progress at the International Thermonuclear Experimental Reactor ITER in France. Recently, the final components of the central solenoid, a key element of the ITER tokamak, were delivered from the United States. This solenoid, critical for producing the strong magnetic fields necessary to stabilize and confine plasma, is a testament to the global commitment to advancing fusion energy. Once operational, ITER aims to generate 500 megawatts of thermal power from just 50 megawatts of input, showcasing the potential efficiency of fusion as an energy source. Meanwhile, at the Oak Ridge National Laboratory ORNL, another significant milestone was achieved when the Department of Energy recognized the Fossil Fuels to Fusion Energy initiative as part of the 2025 State and Local Economic Development Award. This collaboration aims to transform a decommissioned fossil fuel plant into a site for a stellarator fusion prototype, promising to create hundreds of jobs and foster economic growth in the region. The project reflects a broader strategy to position Tennessee as a leader in nuclear energy development. As the world grapples with the urgent need for cleaner energy solutions, the advancements in nuclear fusion technology present a promising avenue for sustainable energy production. Unlike nuclear fission, fusion does not produce harmful radioactive waste, making it a cleaner alternative capable of alleviating reliance on fossil fuels. The potential for fusion energy to mitigate climate change and provide abundant power is increasingly recognized, sparking conversations about its role in the global energy landscape. With ongoing research and international cooperation poised to drive further breakthroughs, the next decade could witness a significant transformation in how we harness energy. While challenges remain, the collective efforts of scientists and researchers in the field of nuclear fusion could ultimately lead to a future where clean, limitless energy is not just a possibility but a reality. As this journey unfolds, the world will be watching closely to see how fusion technology evolves and its implications for energy sustainability and environmental stewardship.